In this video, we are going to be adding and subtracting fractions, specifically with unlike denominators. So that is when your denominator or your bottom number is not the same. In class, we discussed that the denominator has to be the same. We had this big long talk that one cat plus one cat is equal to two cats. And one dog plus one dog is equal to two dogs. But what is two cats plus two dogs? Well, we can't call them four cats. We can't call it four dogs. There's no such thing as a cat dog. So instead, we would have to rename both of them to fit. So four animals, four pets, four furry creatures, four mammals. But we would have to change this word, this label, in order to be able to add them together. It's the same thing with fractions. If your denominator is not the same, you're not talking about the same size unit, so therefore you can't add them together. So let's go about, well, how do you do it then? How do you solve those kind of problems? So we're going to begin with addition. And you're going to see that the steps aren't that different with subtraction, but there are some special cases. So for our first example, we have 2/3 plus 1/4. Students need to know how to find the common denominator. One really good strategy of this is to skip count by both of these numbers. So we're going to skip count by 3, and we're just going to skip count by 4. Trying to find the number in both sets that is the same. So in this example, 12 is the first number we come to that's the same. So we're going to now count what would we need to multiply by. So 1, 2, 3, 4 times 4, and 1, 2, 3 times 3. So over here, we would need to rewrite these problems and kind of stack them on top of each other. So I would have 2/3, I'm going to multiply the bottom by 4, because remember our goal denominator is 12. And I'm going to also multiply the top by 4. I like to say to the students, whatever I do to the bottom, and they repeat, I must do to the top. So now I can say that 3 times 4 is 12, and 2 times 4 is 8. These two fractions are equivalent to each other. I just changed the name of the denominator. I just changed the size of the piece, but not the value itself. And doing the same thing to my second fraction, this time using multiply by 3. Remember our goal denominator is 12. 4 times 3. Whatever I do to the bottom, I must do to the top. 1 times 3 is 3. Now that my denominators are the same, I can add them. I can add these fractions. 8 plus 3 is 11. And I never, ever, 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 ever add my denominators. That is my final answer. Let's look at another example. 4/6 plus 5/8. Again, our denominators are not the same. So in order to make them the same, we're going to skip count by both denominators. 6, 12, 18, 24, 8, 16, 24. You might find that you don't know exactly when to stop, but I've been a 5th grade math teacher for 8 years now, and I know all my math facts, so I know when to stop. You might have to keep going and add back and forth to both of these until you find your right number. So for 6, it's going to be multiplied by 1, 2, 3, 4. And for 8, it's going to be multiplied by 1, 2, 3. All right, friends, pause our thought for just 1 second because my pencil has ran out of lead. So I'm going to have to sharpen a pencil for us to use. All right, back in business. Okay, so now that we know what we're going to rewrite our fractions and stack them on top of each other, just so that I can change them easily and see what I'm changing. So I'm going to use times 4 for this first one. Because remember, our denominator, what we know it already is 24. 4 times 4 is 16. Again, denominator should be 24. They need to be the same. 5 times 3 is 15. Now that our denominators are the same, I can add them. 16 plus 15 is 31. Uh-oh. While this is not incorrect, I told my students and I reminded them that it's like saying 31 over 24 is correct, but it's not proper. This is like walking up to me and saying, "Hey, Taylor," when you know that you should be calling me Miss Joyner. So we need to make this proper. In order to do that, we're going to do long division. We're going to ask ourselves, how many times can 24 go into 31? If you don't know, remember that with these 2-digit divisors on the outside, it's good to take an educated guess and try. So I'm going to try 2 times just to make sure. Well, 48 is a lot bigger than 31, so that can't go in twice, meaning it can only go in 1 time. 11 minus 4 is 7. So our remainder becomes our numerator, and our denominator stays the same. Okay. What if I have 2 mixed numbers? And remember, friends, a mixed number is a whole number and a fraction being mixed together. So if I have 2 and 5/6 plus 1 and 1/3, it looks a lot more complicated, but it's really not. I'm going to take out my wholes and I'm going to add them first. And I'm going to save that for later. Then I'm going to find my common denominator because 6 and 3 are not the same. So 6 and 3. Oh, I'm going to stop there because I've already found my denominator. Remember 1, so times 1, and 1, 2 times 2. Now I'm going to take that information and I'm going to change my fractions. 5/6 and 1/3. Looking at my skip counting, times 1. Whatever I do to the bottom, I must do to the top. 5 times 1 is 5. As you can see, this fraction didn't change, but just to keep into the rhythm of doing all the steps, I like to do it anyway. Excuse me. And then times 2 here. 3 times 2 is 6. 1 times 2 is 2. Now that my denominators are the same, I can add them together. 5/6 plus 2/6 is 7/6. Uh-oh. It's improper again. 6 can go into 7 1 time. Remember, my remainder becomes my numerator. But friends, am I done here? What am I forgetting about? All the way back at step 1, I have that whole number. So my final answer is 3 plus 1 and 1/6, which is 4 and 1/6. So again, let's go through it. I'm going to add my whole numbers, find my common denominator, change my fraction so that they can be added together. If it's improper, change it, and then just don't forget to add that whole number back into your final answer. Now we're going to move on to subtracting fractions. While the steps aren't different, when it comes to those mixed numbers, you can run into some issues. So I'm going to do one example just to show you it's not any different. Again, my denominators for subtraction, I have to have the same denominator as well because I can't take 1 cat away from 2 dogs. I would have to rename them. So 12 and 6 are not the same. So I'm going to skip count to find my common denominator. In this case, my common denominator is 12 times 1 and times 2. Let's rewrite our fractions. Times 1 here, because remember our goal is 12 for both of these. And then times 2 from my skip counting comes here. So 5 times 1 is 5. I know, it didn't change. 1 times 2 is 2. I take these two fractions and now I can subtract them because our denominators, they're the same now. 5 minus 2 is 3. And just like with adding, I never, ever, 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 ever subtract the denominators, the bottom number. Okay, moving on to mixed numbers with subtraction. Again, first step, what you think I'm going to do? Let's worry about those whole numbers. 3 minus 1 is equal to 2. But in this time, okay, I'm going to keep that whole number with my fraction. And let me show you what I mean. First things first, though, denominators are not the same. So let's skip count and find that common denominator. For my 2, 1, 2, 3, so times 3. And for 3, times 2. So I'm going to stack those fractions. But this time, this 2, it goes back with this first fraction. So I have 2 and 1/2, and I have 1/3. So in order to change that 1/2, I need to multiply by 3. Remember, I got that information from my skip counting. And for this one, oh, come on, Mr. Winner, get your life together. 3. And for this one, times 2. Now, I have 2 and 3/6 minus 2/6. My final answer, 2 and 1/6. Okay? It's really important with subtraction that this whole number goes right with this fraction because you might need it. And you're going to see what I mean in this next example. So in my next example, not that paper. We're going to do 7 and 1/10 minus 2 and 3/5. Okay. Right off the bat, first thing that we have to do, whole numbers. 7 minus 2 equals 5. Then, denominators, they're not the same. So let's skip count. 10 and 5. 10 is my common denominator. Let's remember to apply that to our new fraction, to our fraction so we can change it. And don't forget about this whole number here. So I have 1/10. 5 and 1/10. And I have 3/5. Looking at my skip counting here, I'm going to multiply this one by 1. I'm going to multiply top and bottom over here by 2. So I have 5 and 1/10. And I have 6/10. So now I need to rewrite that. 5 and 1/10 minus 6/10. Uh-oh. Alarm bells should be going off here. If I have 1 cookie and Ava wants 6, do I have 6 to give her? No. I can't do 1/10 minus 6/10. So just like in regular subtraction, I need to borrow. But from where? Well, the only place I can borrow from is my whole number. So if I take one whole away, okay, I'm going to borrow and I'm going to take that whole and I'm going to break it up into parts. This becomes a 4. And that whole needs to be turned, that whole that I took out, it needs to be turned into something that I can use. Well, it needs to be turned into a fraction. That fraction is going to be 10 over 10. I chose to use 10 over 10 because that's my denominator. And what good would it do us if I used a fraction that I then had to change the denominator again? So I'm going to then combine these parts because I have 4 and I have 11 over 10. Now, okay, let me go back and let me make sure we understand how I got to that 11 over 10. I have 4 wholes and 10/10 plus 1/10 is 11/10. Okay, I just took, just like if I was doing some, and I know this, jumping all around here just a little bit. Just like if I was doing borrowing regularly, I go over to my tens place and I take away 1. Well, that 1 that I came over here, it's not 1 anymore, it's 10. So this is 13. That's the same thing here. I didn't take 1, I took 10/10. So that's where this came from. Now that 11 is bigger than 6, I can subtract that. So I have 4, wholes, and I have 11 minus 6, which is 5. So as you can see, the problems that are the most complicated are these subtraction with borrowing. And you won't know at first if you need to borrow. You're only going to know once you get to this step. And if this first numerator is bigger than this one, you can't do that and you must borrow. But in this other example that we did with subtraction, if I could find it, there wasn't any borrowing required because 3 is bigger than 2. Okay, so remember the most important steps with adding and subtracting fractions, unlike denominators, is that denominator needs to be the same. And if it's not the same, if that denominator is not the same, we need to do some skip counting to find it. We're going to create equivalent fractions that now are in a position to where we can add or subtract them. And remember that if there's whole numbers, we work with those first. And with subtraction, you might have to pay attention. There might be some borrowing that happens at the end. There might be some borrowing that happens at the end, if necessary. Okay,